All right, everybody. Today's lesson is on relations and functions. And the first thing we're going to talk about here, a definition, is what a function is. A function is a pairing of each number in a given set with exactly one number in another given set. And the key word here for function is exactly one number. All right, so there can only be one thing that matches with exactly one other thing. But we're going to partner these things up in what we call a relation. All right. So, for example here, what we're going to be getting into is something like this. Y equals 5x, which is a function. Okay? Now, what you'll notice here today is that there's two variables in this problem. There's a y and an x, because the x's and the y's are going to go together. And what I'm going to say is the x is going to be one set of numbers. So if I were to go ahead and tell you a number for x, what if I said that x is 1? All right, well, now there's going to be a very specific y that goes with it, and that x and y are going to go together. They're going to have a relation, and they're going to be partnered together. So if I were to take this 1 and put it in place of x, this would become 5 times 1, and so I know that when x is 1, its partner y is going to be 5 times 1, which is 5. Okay, so x is 1, y is 5. And another way to write that is just as an ordered pair, where the x is 1 and the y is 5. We're saying those two things go together, all right? And that pairing there is what we call a relation, okay? The 1 and 5 have a relation together. When x was 1, we got an answer of y equals 5. Now, to go with that, anytime that I change the x, if I were to say that x is 10, well, that's then going to change what my y is, because now if I go back and plug in instead of 1, let's say plug in 10, well then that becomes 5 times 10, and that tells me that y is going to be 50. So when I change the x, the y changes as well, and I would get a new ordered pair or a new relation, which is 10 and 50 go together. So those are relations, that pairing of numbers. This function is when I have an x that is only matched with one exact y that goes with it. We're talking about the pairings here. Okay? So now there's a couple different names that we need to know here, a couple different vocab. All right, the first thing that we're going to write down here are our x's. Okay, the x's are the numbers, like here. The x's are the numbers that we put into the problem, so those are called our input numbers. Input numbers. And then our y's have a special name also. If x's are the numbers that go into the problem and are called input numbers, the y's are the answers that come out and are called our output numbers. So the x's go in, we compute it, and the y's are what come out. They're output numbers. Okay, so x's are input numbers. We also have one other name for the x's. That is also called our domain. So anytime you hear the problem talking about state the domain, they're just simply saying write down the x's. Okay, x's, input numbers, domain, all the same thing. Y's, or our output numbers, are called our range. So if they ever say state the range, so those are some of the names that we're going to need to know. Okay, let's move on. Example 1 says make an input-output table for the function y equals x minus 1 using the domain 0, 1, 2, and 3. Then state the range of the function. Okay, so the first thing that they're mentioning to us here is that this is our function. Remember, a function is just relating two sets together. So our x's are being related to our y's. Okay, so our function is y equals x minus 1. Okay, an input-output table. Okay, well remember, our inputs are really just our x's, and our outputs are our y's. So we're really making an xy table. Now I'm just going to make a little t-chart here, where it's kind of a sideways t. Okay, and what we're going to do now is we have to decide what x's we're going to use. Okay, and since the problem says using the domain 0, 1, 2, and 3, well, those are the numbers that I put in here, 0, 1, 2, and 3. Those are going to be my x's, because that's my domain. What we have to do then is now, one at a time, put those into our function, y equals x minus 1, solve it, and figure out what y's go with these x's. So if I start here with the 0 and put it in here, this becomes 0 minus 1, which is negative 1. So when x is 0, my answer for y is negative 1. And I just have to do this one at a time. So now I have to move on and put the 1 in there. So now if I take this 1 and put it in there, it's going to become 1 minus 1, which equals 0. Okay, so when x was 1, y equals 0. Okay, again, I'm going to rewrite it here so we don't get confused. y equals x minus 1. Now I have to plug the 2 in here, so it becomes 2 minus 1, which is 1. And then finally 3 minus 1, which is 2. Okay, so there's my input-output table. My input are my x's, the output numbers are my y's. Final thing says, then state the range of the function. Remember, our range is just our y's. They're really saying just write down what our answers were. Well, our range was -1, 0, 1, and 2. And that's our final answer. So we made an input-output table using the numbers they told me, the domain for my x's. I took those one at a time, plugged them in the problem, and solved and got the range. Okay, example 2. It says identify the domain and range of the relation in the given ordered pair. So each one of these things is a relation because two numbers are being related to each other. Okay? All we're simply doing is we're going to state what the domain is, and then we're going to state what the range is. Well, remember, our domain are just our x's. 0, 2, 3, and 5. State the range. Well, the range are the y's. 1, 4, 7. And that's it. I actually, even though there's another 4 here, there's 2 4s, I don't have to state them twice. All right, but notice how I ordered these all from least to greatest. I don't have to list any repeats. Okay, so there's my domain and range, and that's all it is. Okay, they're also going to ask us to do something a little different here. Represent the relation, and they give us 5 points as indicated. One is they're going to say represent this relation as a graph, and 2 as a mapping diagram. Okay, well, if I'm going to do a graph, here's what they're asking us to do here. Okay, as a graph, they're simply going to ask us to put these points on a graph. So if I do -1, 1, that's 1 to the left and 1 up. Okay, 2, 0 is 2 to the right, 0 up and down. 3, 1 is 3 to the right and 1 up. So I'm simply going to put these points on the graph. 3, 2 is 3 to the right and up 2. And then finally 4 and then up 1, 2, 3, 4, 5 is going to be way up here. So as a graph, they're simply saying graph the points. Okay? Okay, the second thing they're asking us to do here is as a mapping diagram. And I'll do the mapping diagram down here because it has a little bit more room. And again, all they're really asking us to do is write down our input numbers and then write down our output numbers. And it's just a little different how they want us to list it. Our input numbers, again, are -1, 2, 3, and 4. We're just listing our x's. Our output numbers are 1, 0, 2, and 5. And then they're really just saying, if I have this set of numbers and this set of numbers, so I put groups around it, now it's kind of like just matching them up. The -1 goes with the 1, so I put a line across there. I have a 2 and a 0, so the line can go across there. We have a 3 that matches with a 1, so I put the line connecting those. A 3 and a 2, and then finally a 4 and a 5. So that's what we mean by saying our mapping diagram. Okay, final thing. Tell whether the relation is a function. So again, these are relations because we're relating two numbers to each other. All right? Now remember our definition of a function. What it said, if you remember, way back on page 1 for a function is that when a given number from one set is matched with exactly one number from a second set. So we're saying we're relating our x's and our y's. But the thing is we can't have an x matched with two x's. Okay? X's can't be matched with two different x's. All right, it's kind of like the x's are, cheating on the y's if they're dating. All right, you can't have an x matched with two different y's here. So the one thing I notice here is when I see this. Okay, I see this 5 right here. We're saying 5 is matching up with 65. Well, it's already matched with 5, and our rule says x's can't be matched with two different x's. Well, look at here. I have another 5 for an x, and that's matched with the number 69. Okay? Well, because it's matched with two different y's, even though they are in a relation, we say that this is not a function. Okay? For something to be a function, you can't have any repeats. All right? It can only be matched with one thing at a time. So as soon as you see the 5 matched with two different numbers, that says that's not okay. That's not allowed. Okay? So that's our lesson on functions and relations.